Okay, so welcome back here at the EC Engineering Tutorials. So in previous session, we discussed about the degree of indeterminacy together with the formulas involved for conditional equation, for trusses, beams, and frames. And then uh, we have solved few examples just to illustrate uh, the importance of the degree of indeterminacy. So this time we're going to solve uh, additional problems for the degree of indeterminacy. So again, the problem is we need to determine if determinate or indeterminate. Okay, so we have here fully restrained beam. So again, we have number of reactions. So the number of reaction is we have 3 and another 3 for fixed support. So we have 6. We have no internal hinge or internal roller, so we have 0. So thus the degree of indeterminacy is we have r minus 3 plus EC. So we get the value of 6 minus 3 plus uh, 0. So thus we have 6 minus 3, or we have 3 degree indeterminate. Okay, so this 3 degree is caused by the fixed support. No? So we have 3 reactions. So if we remove that fixed support, so this beam becomes cantilever beam and can be analyzed as determinate structures. So how about if we add the internal hinge? So again, the number of reactions is 3, and then we have 3, and then we have conditional equation here for internal hinge. So the number of reactions we have 3 plus 3, again we have 6. Conditional equation we have 1. So thus the degree of indeterminacy is we have r minus 3 plus EC. So we get 6 minus 3 plus 1. So we have 6 minus 4. So I is 2 degrees indeterminate. Okay, so next is this one. So again, the number of reaction here we have 3. Again, we have roller support, we have 1, so we have 3 plus 1. So we have 4. We have conditional equation, we have internal roller, so EC is 2. So the degree of indeterminacy, we have 3 minus r minus 3 plus EC, so we have 4 minus uh, 3 plus 2, or that is 4 minus 5. So we have negative 1. This is less than 0, meaning this is unstable. So unstable because this member, if we add or we apply horizontal force, so it would translate along its x axis, so it becomes unstable. Okay, so next is We'll discuss further more on unstable in the next slide. So here we have uh, two reactions, one reaction and three reactions. So a total of we have 2 plus 1 plus 3. So therefore we have 6 total number of reactions. For the conditional equation we have 1. Okay, so we have also 1 for internal hinge. So a total of 3 uh, conditional equation. So the degree of indeterminacy is r minus 3 plus EC. So we have 6 minus 3 plus 3. So therefore we have 6 minus 6, 0 degrees. So this is determining. Okay, so that's determining. Next is this one. So again we have two reactions. So we have two reactions, and then we have EC equals 0. So thus the degree of indeterminacy is r minus 3 plus EC. So we have 2 minus 3 plus 0. So we have negative 1. So this is less than 0. Therefore, this is unstable. So we have negative 1. So we need at least one redundant force to make it stable. So as shown here, so example, again, we have reactions. So if we add additional redundant forces caused by the roller support, so this structure will become stable, no? And then determinate. So let's try to check. So the number of reaction, we have 2 plus 1, so we have 3. And then we have no internal hinge, so that is 0. So therefore the degree of indeterminacy is r minus 3 plus EC. So we get 3 minus 3 plus 0. So we have 0 degree. So this is determining. Okay, so next problem is we have again continuous beam. So we have one reaction for every roller support. So the number of reactions we have 2 plus 1 plus 1 plus 1. So a total of uh, 2, 3, 4, 5. 2, 3, 4, 5 reactions. So conditional equation we have 0. So thus the degree of indeterminacy is we have r minus 3 plus EC. So again we have 5 minus 3 plus 0, or 5 minus 3, so that is equal to 2. So we have 2 degrees indeterminate. So which means we have 2 redundant forces that makes the structure indeterminate. So due to this 2 additional mga roller support. Because if we remove that one, that becomes that becomes our beam overhang. So that is determinate, determinate pag overhang beam. Again, here we have reactions. So the number of reactions is we have 2 plus 1 plus 1 plus 1. So a total of 5 reactions. So EC we have again 1 and 1 for internal hinge. So the degree of indeterminacy is R minus 3 plus EC. So therefore we have 5 minus 3 plus 2. So we have 5 minus 5. So we have 0 degree, and that is determinate. So as you observe here, so this structure and this structure are the same. No? So the last structure is just we have added additional internal hinge. So as you see here, we have I, that is 2 degree. So one way to look at this degree of indeterminacy is we need two external hinge to analyze the, or to at least approximately analyze the beam, no? Using the equilibrium equation. So that's why when we add two internal hinge, so our continuous beam becomes determinate. It means that it can be analyzed now using equilibrium equations. So that's another one way to look at the degree of indeterminacy. So for frames, so if you look at for frames is okay. So we count for the number of reactions. So we have 2 for hinge and 2 for hinge. So the number of reaction is we have 2 plus 2, so total of 4. We have no internal hinge, so that becomes 0. So the degree of indeterminacy is we have R minus 3 plus EC. So I is 4 minus 3 plus 0. So we have 4 minus 3, and that is a 1 degree indeterminate. Okay? So another way is, since this is considered also as frames, so we can use the formula for 3m plus r minus 3g plus ec. No? So we count for the number of members. So let's say we have 1, 2, 3, 4 members. For the number of joints, so we have, say, change color. So I have 1. It's including the support. We have 2, we have 3, we have 4, and we have 5. So we have 5 joints, and the number of reactions, again, we have 4, and EC we have 0. So we have 3m plus r minus 3j plus EC. So we get the value of 3m plus r. So yun ko muna yung 3m plus r. So we have 3 times 4 plus 4. So we have 16. And then 3j plus EC, we have 3 times 5 plus EC, we have 0. So therefore we have 15. So the I is 3m plus r minus 3j plus EC. So we have 16 minus 15, and that is 1 degree indeterminate. So, ganun, no? So, we have 1 degree indeterminate. So, so we have, so in order to analyze this frame is, we need one internal hinge, no? We need one internal hinge. So, that can be shown here. So, this is the same structure. I just added an internal hinge. So, let's say if it could be the result. So, again, we count for the number of reactions. So we have 2. So the number of reactions is 2 plus 2. So we have 4. So the conditional equation, since we have internal hinge, so AC is 1. So the I will be R minus 3 plus AC. So we have 4 minus 3 plus 1. So I is 4 minus 4. So we got 0 degrees. So therefore the structure can be analyzed using equilibrium equation. You can also use the formula for internal indeterminacy, where we count for the number of members. So we have 1, 2, 3, and 4. So we have 4 members. Again, we have joints. Number of joints is, we have 1, 2, 3, 4, and 5 joints. So the number of reaction, again, we have 4. AC, we have 1. So 3m plus r and 3j plus EC. So we get 3 times 4 plus 4. So we have 12 plus 4, that is 16. And then we have 3 times 5 plus 1. So we get 16. So I is 16 minus 16. So we have 0. It's determinate. So it means that the structure is determinate externally and internally. Okay, so another example is, again, we have frames. So we have reactions for fix. So we count the number of reactions. So we have 3 plus 3, so a total of 6 reactions. We have no internal hinge here, so we have 0. And then our I is R minus 3 plus EC. So we have 6 minus 3 plus 0. So I is 6 minus 3. So we have 3 degrees indeterminate. So it means that another way to look up for this one is, we need 3 internal hinge in order to make this structure determinate, and for us to analyze it using equilibrium equation. Approximately analyze, not using equilibrium equations. So for instance, this one, no? So I just added internal hinge. So if we count again the number of reactions, so reaction is, we have 3 plus 3, so we have 6. So the conditional equation, we have 1 for internal hinge. So we have 3 internal hinge, so total of 3. So the degree of indeterminacy is R minus 3 plus EC. So we have 6 minus 3 plus 3. So I is 6 minus 6. So that is 0 degree determinate. So it means that this frame system can be analyzed using equilibrium equations. Okay? So that's one way to do it. So if we use the formula in solving for internally indeterminacy, so let's try. We count for the number of members. So we have 1, 2, and 3. Okay, so our members is 3. For the number of joints, we have 1, 2, 3, and 4. So we have 4. So the number of reaction is we have 6 and EC is 0. So 3M plus R and 3G plus EC. So we get the value of 3 times 3 plus 6. We have 9 plus 6, that is 15. And we have 3 times 4, we have 12 plus 0, so we have 12. So our I is 3M plus R minus 3J plus EC. So we get 15 minus 12, and that is 3 degrees indeterminate. So it's the same, no? So also with this one. So if we count the number of members, uh, anyway, you just need to add 3 here, no? For internal hinge. So if you add 3, so this becomes 15, huh? So 15 minus 15 becomes 0. So that's the same procedure anyway. Okay, so let's continue in the next video for additional problems for frames uh, and trusses. Okay, so in the next video you will see a shortcut formula in determining for the degree of indeterminacy for uh, building frames. So let's continue in the next video. Thank you for listening.